object. Return a string containing a printable representation of an object. For many types, this function makes an attempt to return a string that would yield an object with the same value when passed to eval. Otherwise, the representation is a string enclosed in angle brackets that contains the name of the type of the object together with additional information, often including the name and address of the object. A class can control what this function returns for its instances by defining a wrap or method. If sys.displayHook is not accessible, this function will raise runtime error. Reverse sequence. Return a reverse iterator. Sequence must be an object which has a reversed method or supports the sequence protocol, the len method, and the getItem method with the integer argument starting at 0. Round number comma n digits is equal to none. Return number rounded to n digits precision after the decimal point. If n digits is omitted or is none, it returns the nearest integer to its input. For the built-in types supporting round, values are rounded to the closest multiple of 10 to the power minus n digits. If two multiples are equally close, rounding is done toward the even choice. So, for example, both round 0. 0.5 and round minus 0. 0.5 are 0, and round 1.5 is 2. Any integer value is valid for non n digits positive, 0 or negative. The return value is an integer if n digits is omitted or none. Otherwise, the return value has the same type as number. For a general Python object number, round delegates to number dot underscore underscore round underscore underscore. Note: the behavior of round for floats can be surprising. For example, round 2.6752 gives 2.67 instead of expected 2.68. This is not a bug, it's a result of the fact that most decimal fractions can't be represented exactly as a float. See floating point arithmetic issues and limitations for more information. Class set. Class set iterable. Return a new set object, optionally with elements taken from iterable. Set is a built-in class. See set and set types. Set frozen set for documentation about this class. For other containers, see the built-in frozen set list tuple and dict classes as well as the collections module. Set attribute object comma name comma value. This is the counterpart of get attribute. The arguments are an object, a string, and an arbitrary value. The string may name an existing attribute or a new attribute. The function assigns the value to the attribute, provided the object allows it. For example, set attribute x foo bar 3 is equivalent to x dot foo bar is equal to 1 2 3. Name need not be a Python identifier as defined in identifiers and keywords unless the object chosen to enforce that. For example, in a custom get attribute or via slots, an attribute whose name is not an identifier will not be accessible using the dot notation, but is accessible through get attribute, etc. Note: since private name mangling happens at compilation time, one must manually mangle a private attribute's name in order to set it with set attributes with two leading underscore. Class slice stop. Class slice start stop step is equal to none. Return a slice object representing the set of indices specified by range start stop step. The start and stop arguments default to none. Start stop step. Slice objects have read-only data attributes start, stop, and step, which merely return the argument values or their default. They have no other explicit functionality. However, they are used by NumPy and other third-party packages. Slice objects are also generated when extended indexing syntax is used. For example, a start stop step or a start stop comma I. C iter tools dot is slice for an alternative version that returns an iterator. Changed in version 3.12, slice objects are now hashable provided start, stop, and step are hashable. Sorted iterable comma slash comma asterisk comma key is equal to none comma reverse is equal to false. Return a new sorted list from the items in iterable. Has two optional arguments which must be specified as keyword arguments. Key specifies a function of one argument that is used to extract a comparison key from each element in iterable. For example, key is equal to str.lower. The default value is none. Compare the elements directly. Reverse is a boolean value. If set to true, then the list elements are sorted as if each comparison were reversed. Use functools.cmp underscore to underscore key to convert an old style cmp function to a key function. The built-in sorted function is guaranteed to be stable. A sort is stable if it guarantees not to change the relative order of elements that compare equal. This is helpful for sorting in multiple passes. For example, sort by department, then by salary grade. The sort algorithm uses only less than comparisons between items while defining an underscore underscore less than underscore underscore method will suffice for sorting. PEP 8 recommends that all 6 rich comparisons be implemented. This will help avoid bugs when using the same data with other ordering tools such as Max that rely on different underlying method. Implementing all 6 comparisons also helps avoid confusion for mixed type comparisons which can call reflected which can call reflected the underscore underscore greater than underscore underscore method. For sorting examples and a brief sorting tutorial, see sorting how to. At the rate static method. Transform a method into a static method. A static method does not receive an implicit first argument. To declare a static method, use this idiom. Class C at the rate static method decorator def f arg1 arg2 argn. The static method form is a function decorator. See function definitions for detail. A static method can be called either on a class such as c.app or an instance such as c.app. Moreover, they can be called as regular functions such as app. Static methods in Python are similar to those found in Java or C++. Also see class method for a variant that is useful for creating alternate class constructors. Like all decorators, it is also possible to call static method as a regular function and do something with its results. This is needed in some cases where you need a reference to a function from a class body and you want to avoid the automatic transformation to instance method. For these cases, use the idiom def regular function class C method is equal to static method regular function. For more information on static method, see the standard type hierarchy. Changed in version 3.10. Static methods now uh, inherit the method attributes module name, qual name, doc, and annotations. Have a new wrapped attribute and are now callable as regular functions. Class str object is equal to empty string. Class str object is equal to byte empty string, comma encoding is equal to utf-add, comma errors is equal to strict. Return a string version of object cstr for details. str is the built-in string class. For general information about strings, see text sequence type str. Sum iterable, comma slash, comma start is equal to 0. Sums start and the items of an iterable from left to right and return the total. The iterable items are normally numbers and the start value is not allowed to be a string. For some use cases, there are good alternatives to some method. The preferred fast way to concatenate a sequence of strings is by calling empty string.join sequence. To add floating point values with extended precision, see math.fsum. To concatenate a series of iterables, consider using iter tools.chain. Changed in version 3.8, the start parameter can be specified as a keyword argument. Changed in version 3.12, summation of floats switched to an algorithm that gives higher accuracy on most bits. Class super. Class super type comma object or type is equal to none. Return a proxy object that delegates method calls to a parent or sibling class of type. This is useful for accessing inherited methods that have been overridden in a class. Um, the object or type determines the method resolution order to be searched. The search starts from class right after the type. For example, if underscore underscore mro underscore of object or type is d pointer b, then c a an object, and the value of type is b, the super searches c a object. The underscore underscore MRO attribute of the object type lists the method resolution search order used by both get attribute and super. The attribute is dynamic and can change whenever the inheritance hierarchy is updated. If the second argument is omitted, the super object returned is unbound. If the second argument is an object, is instance object type must be true. If the second argument is a type, is subclass type 2 type must be true. This is useful for class methods. There are two typical use cases of super. In a class hierarchy with single inheritance, super can be used to refer to parent classes without naming them explicitly, thus making the code more maintainable. This use closely parallels to the use of super in other programming languages. The second use case is to support cooperating multiple inheritance in a dynamic execution environment. This use case is unique to Python and is not found in statically compiled languages or languages that only support single inheritance. This makes it possible to implement diamond diagrams where multiple base classes implement the same method. Good design dictates that such implementations have the same calling in signature in every case, because the order of calls is determined at runtime, because that order adapts to changes in the class hierarchy, and because that order can include sibling classes that are unknown prior to runtime. Class CB, diff method, self arg, super.method, super.method arg. This does the same thing as super C, self.method arg. In addition to method lookup, super also works for attribute lookup. One possible use case for this is calling descriptors in a parent or sibling class. Note that super is implemented as a part of binding process for explicit dotted attribute lookups such as super.getItemName. It does so by implementing its own getAttribute method for searching classes in a predictable order that supports cooperative multiple inheritance. Accordingly, super is undefined for implicit lookups using statements or operators such as super name. Also note that aside from the zero argument form, super is not limited to use inside methods. The two argument form specifies the arguments exactly and makes the appropriate references. The zero argument form only works inside a class definition, as the compiler fills in the necessary details to correctly retrieve the class being defined, as well as accessing the current instance for ordinary methods. For practical suggestions on how to design cooperative classes using super, see guide to using super. Class tuple, iterable. Rather than being a function, tuple is actually an immutable sequence type, as documented in tuples and sequence types list tuple range. Class type object class type name base dict pointer keywords. With one argument, return the type of an object. The return value is a type object and generally the same object as returned by object.class. The is instance built-in function is recommended for testing the type of an object because it takes subclasses into account. With three arguments, return a new type object. This is essentially a dynamic form of the class statements. The name string is the class name and becomes the underscore name attribute. The basis tuple contains the base classes and becomes the basis attribute. If empty object, then unlimited ultimate base of all classes is added. The dict dictionary contains attribute and method definitions for the class body. It may be copied or wrapped before becoming the dict attribute. The following two statements are created identical type objects. Class X a is equal to 1. Let's do the practical. Class X a is equal to 1. X is equal to type X. Then basis blank. Dictionary a is equal to 1. Class name.x. See also type objects. Keyword arguments provided to the three argument form are passed to the appropriate meta class machinery, usually init subclass in the same way that keywords in a class definition besides meta class. See also customizing class creation. Vars object. Return the dict attribute of for a module class instance or any other objects with a dict attribute. Objects such as modules and instances have an updatable dict attribute. However, other objects may have write restrictions on their dict attributes. For example, classes uses a typed mapping proxy type to prevent directory dictionary updates. Without an argument, vars acts like locals. Note: the locals dictionary is only useful for reads since updates to the locals dictionary are ignored. A type error exception is raised if an object is specified but it doesn't have a ticked attribute. For example, if its class defines the source attribute. Zip pointer iterables comma strict is equal to false. Iterate over several library iterables in parallel, producing tuples with an item from each one. Example: for item in zip 1 to 3, comma sugar, spice, everything nice. Print item 1 1 1 sugar, 2 spice, 3 thing. Print. More formally, zip returns an iterator of tuples where the ith tuple contains the ith element from each of the argument iterables. Another way to think of zip is that it turns rows into columns and columns into rows. This is similar to transposing a matrix. Zip is lazy. The elements won't be processed until the iterable is iterated on. Example: by a for loop or by wrapping in a list. One thing to consider is that the iterables passed to zip could have different lengths, sometimes by design and sometimes because of a bug in the code that prepared that these iterables. Python offers three different approaches to dealing with this issue. By default, zip stops when the shortest iterable is exhausted. It will ignore the remaining items in the longer iterables, cutting off the result to the length of the shortest iterable list. Okay, this one, let me run it. So list, let me print it. So what it will do, list zip range is 3 fee 5 4 form 0 fee 1 5 2 form. This is ignored. Now zip is often used in cases where the iterables are assumed to be of equal length. In such cases it's recommended to use the strict is equal to true option. Its output is the same as regular zip list. Okay, 1 2 3. Like the default viewer, it raises a value error if one iterable is exhausted before the others. For item in zip range 3 fee 5 4 form, strict is equal to true, it will throw an error value error. Without the strict is equal to true argument, any bug that results in iterables of different lengths will be sliced, possibly manifesting as a hard to find bug in another part of the program. Shorter iterables can be padded. Shorter iterables shorter iterables can be padded with a constant value to make all the iterables have the same length. This is done by itr tools.zip.longest. Edge cases with a single iterable argument, zip returns an iterator of one tuple. With no arguments, it returns an empty iterator. Tips and tricks. The left to right evaluation order of the iterables is guaranteed. This makes possible an idiom for clustering a data series into n left grouping using zip iters into n. Strict is equal to true. This repeats the same iterator n times so that each output tuple has the result of n calls to the iterator. This has the effect of dividing the input into n length chunks. Zip, in conjunction with the star operator, can be used to unzip a list. X is equal to this, y is equal to 4 5 6, list zip. So if I print this zip xy, and then this one x2 y2 is equal to zip pointer xy, x2 y2 pointer xy, and x is equal to list 2, y is equal to list 2 is equal to true. Print x is equal to y2 list x2 y2 true. Change it in version 3.10, added the string argument. Thanks.